Hello, welcome everyone back to the John R. Kirk Planetarium. My name is Raj. I'm the director of the Planetarium. I'm your in-person and virtual director of the Planetarium. So behind me, if you can see the scenery, is the John R. Kirk Planetarium at SUNY New Paltz, if you've never been here before. And we're going to take a look at the sky tonight in this show, the virtual sky. So it's kind of a guide as to what you can see when you go outside over the next maybe few weeks or so. And we're going to highlight an event coming up, which is the Perseids meteor shower. So this is an annual event, and it's always falling around August 11th, usually around that date. And hopefully we'll see a lot of shooting stars, a lot of meteors. And actually, this coincides with a live in-person event that I'm pretty excited for. We've been allowed to have 50 people gather on the athletic fields at SUNY New Paltz to actually view this live. And our target date for that is going to be August 11th. And I'm going to give a link at the end and some information about how you can attend that if you'd like. You have to register, and we have to obviously follow the safety protocols. So that's going to be coming up in this show. We're about to begin. I'll just do a couple of reminders. I do encourage questions. If you have any questions, you can put them into the chat, and then that would be a great way for me to view them near the end of the show. So I won't be able to take questions during the show because there's like 10 screens going at once. But if you have a good question, then for sure put it in the chat. And then at the end of the program, I'll do my best to address those questions. And I'd like to thank the Mid-Hudson Astronomical Association for co-hosting this virtual planetarium show. So thank you, MHAA. Thanks, Eric. My colleague and friend Eric Myers is co-hosting with MHAA tonight. So if you hear me say something to Eric, that's who that is. It's not some imaginary friend or constellation in my mind. All right, so we are going to get started here with the sky. So that's the first thing you're going to see is a nice view of the sky. Right, once we get switched up, okay, I think we're looking at the correct thing at this point. So this is the program we use to project the virtual view of the sky, which is called Stellarium. And I've set it up for today, August 6th. If you're not watching on August 6th, that's okay because the sky that you see here is still pretty much what you would see for the next few weeks. We are standing on the walkway over the Hudson, which is our nice little virtual landscape around us. And right now we're looking straight up, but I'll show you what it looks like in real life because you're probably looking in one direction at a time as you view the sky. So it's the middle of the day, it's 12:30 p.m. So I'm just going to switch up our view now. So let's say you were going to stand on this bridge and look south. If you did that, you'd see this view here with the sun in the middle of the sky, high in the sky, in the southern direction. Here we are looking west. And again, I'm going to plug my friend Eric, who took this picture a long time ago on the walkway of the Hudson and made it into our virtual landscape. So thanks for that. You are looking east. And even if you're not in New Paltz, or if you're not actually where this takes place in Poughkeepsie, New York, as long as you're somewhere in the mid-latitudes, maybe 35 degrees to 45 degrees north latitude, you'd be able to see a sky that I'll project here. And here we are once again looking south. So that's kind of our scenery, and I will change the direction according to what we're looking at. So as usual, we start with the view pointing straight up. You see the sun high in the sky. But of course, let's get to the good stuff, which will appear at night. So now I'm fast forwarding through time. And if you are able to view at the bottom of your screen, there is a clock running, which shows you the time. You don't necessarily need to look at that, so don't worry about it. I'll update you on what time this represents as we go through the program. I think I'll pause it here right before sunset. So if we want to view the sun set at this time of year, we'll look northwest. So we can follow that happening. Look at the sun, and it's going to touch the horizon and set in the northwest. Now, the first few stars will appear. And I've set something nice for this evening, actually. I've set up our program to simulate a lot of meteors, a lot of shooting stars. So you're going to see that tonight in this show. You'll see like a streak of light go across the sky, a shooting star or a meteor. They're the same thing, and I'll explain exactly that definition later in the show. It doesn't represent the accurate rate of the meteors that you're going to see for the Perseid meteor shower next week, but it does give you a little bit of a simulated view. So it's a little bit enhanced, but I hope you enjoy that. So keep your eyes open for shooting stars in this virtual show. Okay, now I'm going to make it later. Let's take it to 9 p.m. and then a little bit later where the sky is dark enough for us to view things in the heavens above. I think I'll change my direction. I might look north during this part just to see the change of color of the sky and the stars appearing. Now I'm guessing many of you hopefully got out to see the comet that was visible a few weeks ago, Comet Neowise. So maybe you're familiar with some of this stuff now, which is kind of cool. And if you're not, that's okay too. I'll catch you up to speed. We can't see the comet anymore. People are still asking me, how can I see it? It's pretty far now, so it's faded from visual sight. So we'll focus on some other stuff tonight. Okay, looking straight up into the sky at 9:30 p.m., this is what you would see. And I'm going to start with a really, really bright star at the center of the sky. And this one's going to catch your eye. It's super bright, super high right now. We're starting with this star here called Vega. And I'll show you the constellation that Vega is a part of. It's basically at our zenith, so straight up in the sky. But if you wanted to pick a direction, south is good. Let's say you're looking south and you tilted your head way up, you would see this really, really bright star, Vega. Underneath Vega is the constellation called Lyra. So Vega is in the constellation Lyra. So this is a good one to find at this time of the year. I'll draw out the shape for you, and then I'll zoom in. So you start with Vega, as you can see here, Vega, and you draw a little diamond shape underneath it, little box shape, and then two stars to left and right. So I'll highlight that for you, and I'll actually zoom in because it's a little bit of a smaller constellation. Again, this is called Lyra. Now, Lyra could be many things. Many different civilizations looked at this constellation and made up something that goes with it, but I'll give you the ancient Greek version as the standard version. It's supposed to be the lyre. Lyre is a stringed instrument, sort of like a harp. And they said in the ancient Greek stories that this harp was played by Orpheus. So this is Orpheus's lyre in the sky. Now what I actually want to do is take down that picture and focus on something that cool that is in Lyra that we can't see with just our eyes. We need a telescope to see it. So this is our first deep sky object of the night. So you're not going to see it right now. So I'm going to clear away the previous images and put onto the screen a lot of little hints that show us what can be seen with an optical instrument. And one of the best ones to view in the summer is right here in Lyra called the Ring Nebula. So I'm going to zoom in on this one. The Ring Nebula is a dying star. The object we're looking at is called a Planetary Nebula. So let's take a close-up look at that. We'll zoom in. This is a really, really beautiful object. It's a sun-like star, or I would say it used to be a sun-like star, so a low-mass main sequence star, and now it's not a main sequence star anymore. So it's kind of ending its life, and it's expanding and creating this beautiful shell or ring, hence the name, the Ring Nebula. So nebula is a cloud of gas and or dust, and there's different types of nebula. So this one is a planetary nebula. What a planetary nebula is, as I said earlier, it's the death of a low-mass star. So when a star like the sun ends its life, it's not going to go out in a violent explosion. That's something different. That's called a supernova. What happens here is the outer layers of the star's atmosphere puff out and are ejected into space. So that's what you're seeing here. The remaining object in the center is the core of the star that once existed, which is called a white dwarf. So this is like, I think, one of the best examples of where we can find a planetary nebula in our night sky. The distance to the Ring Nebula is 2,600 light years. The white dwarf in the center, which is a little white dot in the middle, is about 0.6 times the mass of the sun. And the temperature of that white dwarf is about 125,000 degrees Kelvin. So that's really, really hot. It's a small, condensed, hot core of the star that once existed. Now that white dwarf is here, it's just going to fade out over time, and this whole ring structure you see here, the layers of gas, are just going to puff away into space. Astronomers can tell that the ring nebula has been expanding for 1,610 years, and it's expanding at a rate of about 20 to 30 kilometers per second. That's pretty fast. So again, it's just kind of like a puff of smoke, sort of like a ring of smoke, and we can see this really well in our observatory. It's composed of the elements hydrogen, oxygen, and nitrogen that's in this nebula part. And it's pretty large. The diameter of the nebula is about 1 light year. So it's much, much bigger than our solar system or any star. So at the end of the star's life, it puffs up, gets really big, and just sheds these outer layers. Again, it's not violent. It's not a supernova. It's a different thing. And I will add that Planetary Nebula is a really bad name because people tend to think of planets and what kind of planet this is associated with, but it's not really have anything to do with planets at all. It's just called a planetary nebula. Okay, so that's kind of our first stop. I'm going to zoom out now in our view of the sky tonight. Let's go back to a straight overhead view. Again, 9:30 p.m. Next constellation I want to hit is also a really well-known one, and it will stand out this time of the year. We're going to look at the western part of the sky now. So I'm going to change the camera to look west, and we're going to hit Corona Borealis. I like Corona Borealis because this one actually does look like what the ancient Greeks had imagined. So you look west, and about not too high up, about maybe 35 to 40 degrees up, you get this nice C shape. And I always remember C for Corona, Corona Borealis. So Corona Borealis means the northern crown, and that makes sense because you can imagine a crown here. I'm going to make it a little closer. Don't you wish you could do this in real life? It's just bring everything closer and clearer into view. And imagine a crown. So, the northern crown. The main star of this constellation, the brightest star that we can see in this constellation, is called Alphecca, which is highlighted here, also known as Gemma. It has a couple different names. Alphecca is the Arabic name, which is the standard name that we use. We use Arabic names for the stars. However, Gemma is also an associated name, and I like Gemma means the jewel. So since it's the brightest star of Corona Borealis, it's kind of like the crown jewel. So that one is nice to find. Look for that C shape. It might look like a little bit of a smiley face to you. And you'll need some pretty clear skies, pretty dark skies to see that one. Again, keep your eyes open, everyone, for shooting stars. If you joined us a little bit later, I set the program tonight to increase the rate of meteors that we would usually see in order to prep us for the Perseid meteor shower, which is coming up. Next, we'll make it later. So I'm going to just fast forward through time. You can see that as the Earth spins in its natural rotation, the sky above us appears to be spinning as well. And we stop here at 11:41. And now you can see a familiar sight come up. The moon is going to be up tonight on August 6th. We will zoom in on the moon because everyone loves the moon. It's an easy thing to find. So if you can't find anything I showed you in this show tonight, try to find the moon. That's a good place to start if you're out there. You got to wait pretty late, though. It's not up right now. You have to wait till about 11 p.m. And we actually have a pretty large moon phase. It is a waning gibbous tonight. So that means it's going to actually create a lot of light in this general region. So I don't think we'll see many meteors yet because the moonlight is still pretty bright. But as the next few weeks go on, the moonlight is going to be waning more and more. And so that will actually clear up our skies, make our skies a little bit darker. So I'm optimistic that we may catch some more meteors. So we got the moon in the east-southeast. And I'm actually going to pivot to the south now. And here's something you may have seen before. If you look south, there's these two really bright dots. Two very bright dots. Now, these are not stars. These are planets. So we got Jupiter and Saturn. Jupiter and Saturn. And I highlighted those last time if you were able to catch our show. So I won't do too much on Jupiter and Saturn, but I would like to point out their location in the sky. Notice how they're kind of next to each other in a line. they're not always next to each other, but the planets will always line up on an imaginary plane that's called the ecliptic, and the moon will usually be around that line too. So I can highlight that here in our planetarium. You can see this red line is called the ecliptic, and the ecliptic is the plane of our solar system. And so if you're looking at a planet, you can rest assured that it's usually somewhere on this line, the ecliptic. Maybe a little bit above or a little bit below, and the moon, as you can see, can be a few degrees off of that. But they'll always generally be somewhere on this line. All the planets will be lined up on the ecliptic. And that's simply showing us that the plane of our solar system is a flattened disk, with the planets occupying pretty much the same flat disk plane. So that's a good test. If you're not sure if you're looking at something that's a planet or a star, if there's another planet that you can see and confirm that it's a planet, and see if the object you're looking at is on that ecliptic, then you can confirm that. So that's kind of cool. Okay, so we got these two planets. I'll have to do a quick zoom up just because they're so cool. So let's do a quick zoom at Jupiter. Here's Jupiter with many moons labeled. So this is a great thing, of course, to look at if you have a telescope. And I'm just going to slew across the sky here. Saturn is also really, really great right now. So these will be the highlights for the rest of the summer, if you have a chance to look at them. Here's Saturn with its rings. But for now, I'll zoom out and just, again, show you the view of the three solar system objects that we can see right now: Jupiter, Saturn, and the moon. So look for those. Jupiter is going to be extremely, extremely bright, brighter than any star, so you should be able to see that one pretty easily. All right, now we'll move it along a little bit and look for another deep sky object. So I'm actually going to just pivot us to look in the southwest now. And once again, put on our list of deep sky objects. So here we are now looking in the heart of the Milky Way. The center of our Milky Way galaxy is in this direction. And I'm going to focus on another nebula called the Trifid or Trifid Nebula. So this is a very different type of nebula than the one I showed you previously. The one I showed before was a planetary nebula. This is a different thing. It's a more complex system, I would say. So let's go ahead and zoom in now. Here we are to look at the Trifid or Trifid Nebula. So nebula, again, is a cloud. Think of a cloudy thing, maybe filled with fine dust particles. And this nebula has all types of different components. The distance to this nebula is 4,100 light years. And we generally have three broad groups for different type of nebulae that we can study. This one's got them all. So we have a Emission Nebula. That's this pink rosy colors thing you see here. So look for the colors. This pinkish area is the Emission Nebula. We have a Reflection Nebula. That's the dark, that's the blue part here. The blue part is reflection. And then the dark nebula is just the dark parts. So I think I see them easily within the Emission Nebula. You can see these dark lines and dark bands that are kind of dispersed in here. That's the dark nebula. And they're each showing us a different physical situation. To top that off, this area also contains an open star cluster. So a newly formed group of stars is lighting up this gas and dust. The Emission Nebula, again, that's the pink area here, is hydrogen gas that is excited by the light that these new stars are making. So when you excite hydrogen gas, it becomes ionized and it will glow pink color. So that's excited hydrogen gas. Here, the blue part, the Reflection Nebula, can be gas and dust that's reflecting the light from the new stars. So new stars is making light, and then it gets bounced around and scattered by the dust here, and that gives us the blue color. The dark area here, the dark nebulae, where you see these lines, are where the gas is so dense that it's absorbing the light from what's coming behind it. So it's very dense gas here clumping up together. And when gas is in dense clumps like this, it will trigger star formation. So that explains the presence of the new stars, open star cluster. So it's got like a trifurcated body to it, hence the name the Trifid Nebula. all three different types of nebulae, and newborn star cluster. So this is a favorite amongst many astronomers, and there's many more nearby nebula, but I'll just focus on that one for now. Okay, looking back up into the center of the sky now. Now I'm going to shift to a group of constellations, which is appropriate for our show. You might be asking, what's the deal with Perseus? Or what is the Perseids? Or who was Perseus? And we can actually find this character, this Greek mythological character, in the sky and the associated constellations. So now I'm going to share with you the story of Perseus. In order to do that, we'll make it a little bit later. So you can watch now, the sky is going to change. And I'm going to get it really late. If you really want to see Perseus, around the Perseids, you have to stay up pretty late. It's past midnight for sure. I'm going to make it 2:30 a.m. Okay, here we are at 2:30 a.m. And there's a lot of different constellations that are glued together. So I kind of like this whole thing because it leads us through the sky in an interesting way. To retell the story of Perseus and the family, the royal family of Ethiopia, we need to look towards the north. So let's reposition our camera. Looking north, a little bit northeast. Okay, so there's a lot of constellations that go together in this one. Again, this is a Greek story. Of course, the Greeks weren't the only culture that told stories of the sky, but they're, for better or worse, the more well-known culture of the sky. So I'll stick with that for now. Okay, one of the main characters we have to look for is the Queen Cassiopeia. So you can look northeast. This one is really, really prominent. The Queen Cassiopeia makes this zigzag shape, and it sort of looks like a 3, a jagged 3. That's Cassiopeia. That is the Queen of Ethiopia. She doesn't really look like a queen, but we can draw a picture of her. So this is the Queen of Ethiopia, and then her partner is next door. We have the King Cepheus. So you look next door, a little bit more north, and you get a box of stars here. Box of stars with a point. This is called Cepheus, which is the king. So Cassiopeia's partner there. I really don't think it looks like a king at all. I think it looks like a house. Like in this view, an upside down house, but that's okay. We don't necessarily have to see the image of king and queen the way others do, but it's presented here just for us to enjoy that. So the story goes, we had the king and queen of Ethiopia, and I would say they weren't the best parents. They had some questionable parenting styles. Their country was going to be attacked by an evil sea monster because they angered the gods. So there's an angry sea monster that's coming to destroy Ethiopia, which I'm going to show you in a bit. And they decided, what? We can't do that. Let's sacrifice our daughter to the monster instead. Ugh, I don't know if they should have done that, but they did in this story. So the daughter is called Andromeda, and Andromeda is right next to them. So the way I find Andromeda is I look for this 2 line of stars, and I always remember that looks like a big capital A. So A for Andromeda. Like here's the tip. Here's one line. Here's another line. And then if you were to bar it in the middle, you'd get A for Andromeda, or in this program it looks more like a wishbone type of thing. I'll zoom in a little bit if it's a little small. So there we have Andromeda. So this is their daughter, the princess. And they decided we're going to sacrifice her to this evil sea monster so that, the sea monster kills Andromeda and not the rest of us. So she's actually chained up in this picture. Andromeda is usually depicted chained up to a rock. Not a great thing to do to your daughter, I think. But don't worry, there's a happy ending to the story. I can show you the sea monster next. So we're still looking at, now we're looking a little bit east, and we have to look pretty low in the southeast actually to see the sea monster. So the sea monster is called Cetus. And in some depictions it's like a huge whale, in others it's like a kraken type figure. Here I'll show you the whale version. So here's the head of Cetus. Circle of stars. It's got a neck and then a pretty large body that branches out from that. So I'll highlight the lines so we can see that better. There is Cetus the sea monster, or the whale. So I think that one looks pretty cool. So there's the monster, or the kraken, coming to destroy Andromeda. But don't worry, continuing with the story, Andromeda was saved by one of the most important Greek heroes that was happening to pass by, which is Perseus. Perseus is one of the main characters for tonight, hence the Perseids. So to look for Perseus, we're going to look right basically below Andromeda in the northeast. The way I find Perseus is first I find this very bright star called Myrfak. This is Myrfak. And then that's kind of the body of Perseus. He's got a leg, a long leg, a short leg. Top part, this is maybe his head, and he has like a triangle hat, an arm, and then another arm. I know that's kind of hard to follow. To some people, it looks like a giant starfish. My students often say that it's Patrick from some show. I want to say SpongeBob. But you can imagine it any way you want. Here in our program, it kind of just looks like a wishbone shape. So there's Perseus. This is the radiant for the meteor shower. So I'll explain what that means in a little bit. The radiant basically is where the shooting stars appear to originate from. So that's why it's called the Perseids. Now I think what's also cool in the Greek mythology is Perseus is telling you who he is in his name. It's Perseus. Or if I were to change the S to a Z, just make a simple change. S to Z right there would be Perseus. Perseus, which means this is the offspring of Zeus. And that's like most of the constellations in the sky, actually. So Perseus isn't unique in that way, but he is named after the offspring of Zeus. So Perseus kills the sea monster Cetus, saves the day. So there's Perseus. Hard to imagine a Greek hero with just 2 lines, but you can do that there. In this depiction, you can see he's holding the head of Medusa, which is kind of cool. So Perseus killed the evil monster Medusa and actually used her head as a weapon. And we're not done. There's one more. Perseus was obviously saving the day, so he had his trusty steed, and that's the horse, flying horse Pegasus. So we can now find Pegasus. If we look back towards Andromeda, we take this star and make a box. Make a box for the body of Pegasus. Make a long neck, and then a head, and even some legs coming off here. So this is Pegasus, which is Perseus' horse. Horse with wings, so flying horse. Of course, they couldn't make it just a simple creature like a horse. It's a mythological flying horse. So, you know, there's different versions, of course. We all don't have to tell the Greek stories, but I thought it was nice to bring that up with all of these constellations related to each other. So I'll take down the pictures once again. You can find all these. You do have to stay up late, though, well past midnight. Around 2 a.m. they should be, 2:30 a.m. they should be visible enough. So just to review, Cassiopeia, and I'll show you the boundaries here. Cassiopeia, Cepheus, the king, the queen, and the king. And then Andromeda, the princess, evil monster Cetus, the hero Perseus, and then the flying horse Pegasus that he rode in on. So that's a nice little background mythological story. But now let's get to the actual physics of what we're going to see with the Perseids meteor shower. So I'm going to focus on Perseus here. So that concludes the first part of our show where we're looking up into the sky. I'm going to transition here, and you should see a little slideshow telling you what's going to happen with the Perseids. So I'm going to switch to that now. Okay, so the first picture that you should see coming up is a picture of the, this is a nice time-lapse picture, okay, coming into view now, of that someone took of a previous Perseids meteor shower night. So this is kind of a really nice one. You won't expect to see this many streaks of light at once, okay, so don't go out there expecting all this to be flying out the sky at the same time. This was definitely taken over a longer period of time, several minutes, maybe even longer, to capture these streaks of light. So we're looking for these shooting stars going across the sky. That's what we're going to see next week, the Perseids. Now, a little more background about, what this all is. So here we have an animation of a shooting star or a meteor going across the sky. So hopefully you've seen this before. If you ever look up at the sky and by chance something streaks across the sky, a quick dash, that is a meteor or a shooting star, colloquially named. Shooting star is a really actually bad term because it's not a star. It doesn't have anything to do with the star really. Really, a shooting star is a little piece of dust that comes from space and burns up in Earth's atmosphere. So a very small object, typically grain of sand or piece of dust or pebble sized, usually not much bigger than that. And it's traveling at such incredible speed that it'll burn up, disintegrate in the atmosphere. And that's causing that streak of light to form actually in front of it. For example, I'll give you the entry speed of the Perseids. So for the Perseid meteor shower, the entry speed of these little tiny particles is about 59 kilometers per second. Okay, so even though they're really small, they're traveling extremely fast. 59 kilometers per second is about equal to 130,000 miles per hour. So think of something traveling 130,000 miles per hour. The friction in the atmosphere is so intense that it will burn up. And for these Perseids that we're going to see, they burn up about 120 kilometers above the surface. So it's not like dangerous or anything. They're not going to, most likely not going to do any harm. They're just burning up in the atmosphere. So we want to catch those. Okay, you may have wondered, what is a meteor, a meteorite, and a meteoroid? They all sound similar, but this graphic does a good job explaining it. A meteoroid is an object that is in space, maybe like a pebble or grain of sand, or maybe a bigger thing like a boulder that has the potential to maybe hit the Earth's atmosphere. Okay, so it's just a piece of rock in space, meteoroid. If this object comes into our atmosphere and burns up and creates like a streak of light through the sky, we can call that a meteor. Maybe we'll see a big version of this in our view of the Perseids, and that if you see like a bright flash and something kind of explode in the sky, you can call that a fireball. And then if you have a big enough object, maybe the size of like a baseball or bigger, basketball size, it can burn up partially in the atmosphere, but then some of it can actually survive and hit the ground, and then you can go pick it up, and that's called a meteorite. Here are some examples of meteorites. There's tons and tons of good examples if you'd like to check these out at various museums. If museums are open, you can go and touch some of these meteorites. Some of them have a lot of iron in them, so they're very heavy, very dense. Others are more stony, so they have carbon and other elements like that in there. So there's different categories. Some have very precious metals and are very valuable. So there's lots of meteorites that are mostly on display in museums. So we're looking for meteors when we look at the Perseid meteor shower, this type of activity. So how do we get a meteor shower? Okay, let's back up. What's producing this stream of particles? Well, it begins with, I think, something that many people are now more familiar with than they were before, a comet. So if you remember a few weeks ago, we all went kind of nuts for Comet Neowise. This is not a picture of Neowise, this is just a different one, but I want to remind you what a comet kind of looks like. A comet is an object that's kind of like an icy, dirty snowball. Comes from very far in our solar system, and when it comes close to the sun, it will create this tail. So comet creates a tail behind it. The tail is made mostly of gas, but also bits of ice and rock and dust. So that comet, as it's orbiting the sun, creates a trail of debris behind it. So that's where it starts. And if Earth happens to go through that trail of debris, they'll burn up in our atmosphere and we'll see a meteor shower. So here's an example of a cometary action on the nucleus. This is a comet called Comet Hartley. It's a close-up picture. And you can see these pockets of areas on the comet which are sublimating. So sublimation occurs when ice goes directly from a solid form into a gas form. So as it's sublimating, it releases gas, but not just gas. Little tiny bits of rock are also spewed out. Okay, and this happens because the comet is close enough to the sun. The nucleus gets heated up, so it sublimates. So it's really the sun that's causing all of this. The solar wind, the solar photons, so the actual sunlight, particles of light, push these little pieces of dust away from the comet nucleus and stretches out the tail. So again, I hope everyone saw this with Comet Neowise. That was really cool. Comet Neowise had a very bright, naked eye, easily visible tail. Little bits of dust were getting spewed out from that. Now, not every comet is associated with a meteor shower. For a meteor shower to happen, the Earth has to pass through where that comet has been. And the cool thing is the comet doesn't have to be there recently. So here's the orbit of the comet that creates the Perseid meteor shower. We're looking at the orbit of a comet here, which is called Swift-Tuttle. And as you can see, every 133 years, it dips into the inner part of the solar system and swings way out. It last approached Earth in 1992, and it will return in 2126. So I don't think anyone here is going to be there for that. 2126 is when this comet will come back. But that's okay, because we can still see the effects of it with the Perseids meteor shower. It was discovered in 1865 by Giovanni Schiaparelli that this comet was the source of the Perseids. So people, of course, had observed the Perseids before, but Schiaparelli actually identified it correctly as the trail of debris that this comet produces, Comet Swift-Tuttle. Here's just another look at the orbital properties. So I think this is really cool, the orbital dynamics of how this comet swings into the inner part of the solar system and then goes far away. So it's not close to us now. Again, it last approached Earth in the year 1992. The eccentricity of the orbit is 0.96. So that's very impressive. 0.96 means that the orbit is incredibly stretched out, as you can see here. It's very, very elliptical. It's not resembling a circle at all. The closest distance that this comet gets to the Sun is 0.95 AU. That's called the perihelion. And the furthest that this comet is from the Sun, that's called aphelion, is 51 AU. AU being the distance between the Earth and the Sun. So as you can see, this comet really varies wildly in its distance to the Sun. And this is the nice thing. Just by chance, by mostly, I would say, coincidence, Earth happens to pass through that trail of debris that the comet leaves behind in its wake. So every year in August, you can mark it down on your calendar. It's going to be August 11th or 12th, pretty much every year. The Earth will plow through this stream of tiny little bits of dust, okay, left behind by the comet. So the comet doesn't have to be near us. The comet's not near us anymore. It went by a long time ago, but the trail remains because it's orbited the Sun many times, so it's created this trail. And from our point of view, when these meteors enter the Earth's atmosphere, they burn up. It looks like they're coming from the stars in Perseus. So recall the constellation Perseus from earlier. So that's why it's called the Perseids. So that is where it gets its name, the Perseid meteor shower. And there are other ones. This is not the only one. Throughout the course of the year, there's like 10 really good ones. There's the Geminids, for example. The Geminids seem to originate from the constellation Gemini. And then there's the Lyrids. We saw Lyra earlier, and many others. So this is, I think, one of the most popular meteor showers in the course of the year. So let's try to enjoy it. It looks like they're coming from Perseus. Keep in mind, these little pieces of dust have nothing to do with Perseus or the stars that make up that constellation. The stars that make up the constellation Perseus are light years away from us. So it's not like they're causing the meteor shower in any way. It just looks like it's coming from that general direction. So that's the radiant. So for each meteor shower, we have a radiant. It's the point in the sky that these shooting stars will appear to originate from. So if you trace the shooting stars back, they'll come from somewhere around Perseus. Now don't worry, you don't have to be able to know where Perseus is. In fact, when I'm observing the meteor shower, I usually don't even catch Perseus because it rises pretty late. You just want to look straight up and get a wide view of the sky, and you should be able to catch some of these. If you are up past midnight, and the best time to view a meteor shower is like right before dawn, then Perseus is a good place to kind of look because the meteors will appear to radiate from there. An analogy of this radiant is, imagine you're driving through a blizzard. Okay, you don't probably want to be doing that, but imagine it's snowing, okay, and it's really heavy snow, and you're driving through that. Have you ever seen that before? From your perspective, it looks like all the snowflakes are coming from one spot. And so it's not necessarily the snowflakes are coming from one spot, it's that you're driving through the snow. You're driving through the snowstorm, and so it almost looks like a snow radiant. It's very similar to what's happening here. The Earth is like driving through or plowing through this trail of debris. So that's why it creates this radiant effect. So let's give you a little preview. In this year, 2020, I think we can expect, experts say we can expect 40 to 50 meteors per hour during the peak. So that's pretty good. Most of the time when we're observing the sky, nothing happens, that changes at all. So if you get 40 to 50 new things, streaking across the sky per hour, that would be good. On good years, when we don't have a lot of moonlight, when we're near new moon during the Perseid meteor shower, we can get like 100 per hour. This year we won't get that many because again the moon is going to be interfering with this. The moon's going to cast a lot of light, so we won't see as many. But 40 to 50 would be great. In my personal experience, usually the amount that they predict is way too high. So if we can get like one meteor every few minutes, that would be pretty cool. So again, let's try to view the meteor shower. There is an event on SUNY New Paltz, on the campus of SUNY New Paltz on August 11th. I'll be your host, and we will be outside, so don't worry, it's a safe environment. We're going to be outside, and we're going to be spread out across a large soccer field. And the best way to view this, like how do you want to view it? Lie down, get a blanket, lie down, and look up, look straight up. Don't go outside and expect to see something, within the first 5 to 10 minutes. And don't go outside and look up into the sky for many hours at a time. You're going to really kill your neck. So don't try to like stare into the sky. That's not good for you. Try to lie down, cuddle up with someone that's in your family, hopefully, and then you can look up, and that's a good way to view it. So that's what we're going to be doing. If you're interested in that, there's a link on the SUNY New Paltz John R. Kirk Planetarium webpage. You can go there, and there's a button called Reserve Tickets. We are going to take the first 50 people. Okay, so space is limited. All right, that will end our show. And I'm going to switch it up. I'm going to start the video again. So hopefully you should see me again at some point. Hello. All right, so thanks for watching. Hopefully you learned something there. That concludes our show there, preview of the Perseids. All right. So thanks for joining us. I'm happy to take questions. If you have questions, it's a good idea to put that into the chat feature there, and I'm happy to take those. So Eric is my buddy who's hosting this. Eric, are we still alive? Yes. Thanks, Eric. Any questions that, are you seeing questions on Facebook, on the SUNY New Paltz Facebook? Or any questions that we should look at in the chat from the Zoom? Let's see. Okay, I'm opening that up. Any questions? I am looking at the New Paltz one. I don't see anything there right now. Any questions? I see. There. You can put, I guess, put your questions into the comments area if you're joining us on the Facebook stream. Okay, great. I got to thank you. Thanks for watching. I'll give a little more information if you're thinking of a question. So where you want to go for your tickets for the meteor shower is, again, newpaltz.edu/planetarium. newpaltz.edu/planetarium. It's pretty easy to get to, or just Google New Paltz Planetarium. You'll get there. Then there's a button, and you click that, called Reserve Tickets. It's going to ask you to purchase your tickets, but it's free. So don't worry about that. It just asks you to put in your name and your email address and some information, and then it will reserve you. We have a limit of 5 tickets per group, okay, 5 tickets per family. We are requiring that you stay within your own family. You must wear a face mask when you are there because we want to be extra cautious. And we are going to have cones marking out where each group should set up their blankets. So set up your blankets. I'll have a speaker system. I'll have my laser pointer so I can point out the constellations while we stargaze. Hopefully we'll see meteors shooting across. So that's scheduled for August 11th, 9 p.m. The sky usually does not cooperate with our live events like this. So we have backup dates of August 12th and 13th if it's too cloudy. All right, so we'll make that decision on the day of. And then if you can't join us for that one, I would recommend keep watching over the next few nights, because although the peak of the meteor shower will pass us, the moonlight is going to wane. And so as the moonlight wanes, we see darker and darker skies. And in general, when you want to view any type of meteor shower, you want to stay up as late as you can, past midnight. Right before morning is a good time to observe, if you can do that. And so that will be good later on, after the peak. Because if you go out in the morning of August 11th or 12th, you're going to see a pretty big moon, and that's about it. Yep. Question coming in? Yep. Mm-hmm. Okay, great. So I had a question. I don't think everyone can hear that, so I'll just repeat. Um, Question about mask wearing during the event. We are going to have everyone wear their masks to be safe while you're entering. So there's a little parking lot, a little pathway. So keep your mask on. Once you're in your group settled with your family, then it's okay. Um, Take it off. But if you're doing anything else, put your mask on. So only when you are in your respective group area is it allowed. Just because we want to be extra cautious. So thank you for that question. Okay, I'm seeing some questions roll in now on the Facebook. It's a good thing I have that. All right. So I have a question here that says, will the dust particles ever dissipate to the point where this meteor shower will no longer happen? Good question. Will the particles ever dissipate to the point where this won't happen? Not for a very, very long time if it does, because the comet goes around the sun. Doesn't have to happen too often, but it's 4.6 billion years of this action. Okay, and so it's created a tail, and maybe even if it's a comet that's now no longer actively sublimating, those particles will remain in that area for a pretty long time. Will it eventually dissipate? Maybe it'll get weaker, but that's like over very long periods of time. I'll estimate like tens of millions of years, I would guess. I don't think in human history anyone's ever seen a meteor shower like dry up. I think it takes much longer. So for as long as we'll be here, this will still happen. It probably won't dissipate, is my best guess. But I mean, things can change over a billion years. There could be something that changes. So thank you for that question. That was from Robin Alice. Thank you. All right. So anyone else? Questions? Yes, I have a question coming in on my headset. Go ahead. I will translate your question because we're only doing the feed through my mic right now. So you can ask it. So I'll hear a question, then I'll reiterate. Yes. hmm Okay, thank you. Good question. So that's from Eric. There are various meteor showers throughout the year, and have all of them been identified as to which comet produces that? So which trail of debris we're going through? I would say for the big ones, yes. For the well-known ones, I think about 10 to 12, it's pretty well known which comet does produce that stream. Off the top of my head, I can't think of any that are unknown, but I think it's likely that there could be some that are unknown. And some meteor showers may be so weak that we don't even know it. Like the trail of debris may be so dispersed that it's not really even a meteor shower well known. So it could be possible that there are some like that. Off the top of my head, I cannot think of any meteor showers that for which we don't know which comet it's associated with. One interesting meteor shower is produced by the comet or asteroid, comet slash asteroid Phaethon. And Phaethon is now dead, like it's not sublimating anymore, but we still have the remains of that because we have a meteor shower caused by it. So that's kind of cool. Um, but thank you for that question. I'm not sure off the top of my head. I think the answer to your question is most meteor showers we have a good idea of what comet it's coming from, at least the big ones. Okay, thank you for that question. All right, just checking on the other site here for anything. Okay. And again, I'm just going to plug our co-host. So thank you, Mid-Hudson Astronomical Association. They were co-hosting this event, this live stream. If you'd like to learn about the Mid-Hudson Astronomical Association, or MHAA, you can visit them at midhudsonastro.org, midhudsonastro.org. There's a way you can sign up. They are a group that's really, really into astronomy and does a monthly lecture series. and other cool events like stargazing nights, star parties, help set up your telescope. Like I get a lot of emails from people saying, I got a new telescope, but I have no idea how to do it, how to use it. And so Mid-Hudson Astronomical Association is a good place you might want to check out once we're allowed to gather in groups again. They're doing a lot of online stuff right now, a lot of Zoom videos and guest lectures. So check that website out, midhudsonastro.org, if you're interested. All right, looks like we are almost done. I have a question. Why do we see different colors in some stars like a plane? Thank you. Uh, you are going to see different colors of different stars based on their temperature mostly. So the stars don't all have the same color. Some stars are white. Most stars are kind of whitish, but if you look closely, you have blues. Those are the really hot ones. So blue things are really, really hot. Then you'll have more orange color stars than redder stars. So as you go towards the red end of the spectrum, the cooler the star is. So we're actually seeing the surface temperature of those stars. So you can actually see a nice handful of red stars, if you know where to look. Orange stars, white, and blue. So next time you're out stargazing, focus on the colors. You can actually pick those out, and that's due to temperature of their surfaces. Question about ticket sales on hold. Yes, ticket sales. You can't get them now. They're going to be available on August 9th. So Sunday night is when that link will be live. So you can click it now and it'll say they're on hold. We're on hold right now just because we want to make sure that we can adequately broadcast the information so that everyone who's interested can get on there. My suggestion is to get on that website right at that time and get your tickets because I think they'll go fast. So we're just, we're getting all the information out there. All right, let's wrap it up. It's a nice, hopefully it's a nice night where you are. I think it's cloudy here in New Paltz, but if you have a nice night, go out and look at the stars. Thanks for coming, everyone. We'll hopefully see you next time at the John R. Kirk Planetarium, either in person, hopefully in the future, or for now, virtually. So thanks. Good night, everyone.